Hi all. So this is going to be our day 12 of Google Cloud Fundamentals training. The topics that we are going to cover are Google Cloud Networking Services. It's a continuation of previous session. So we'll talk about the network service tiers, CIDR range, CloudNet, cloud load balancing, and we'll end up with the connectivity options, like the various options available on GCP to establish a connection and try to access the resources from them. Okay, so let's get started. So about the network servicing tier. So let me share another screen again. Is it visible? Can someone confirm it?
Yes, visible.
Okay. Fine. So now we are going to discuss about the network service tier. So last time when I was discussing about there are two tiers and they have their own advantages and disadvantages. So same thing we are going to look a bit more deeper. So the two tiers that we talked about, one is the premium tier, another one is the standard one, right? The premium one is one which is more of a global deployed in a global region, you can say, or it is providing me accessibility of the resources to the internet in a global infrastructure. Okay, but when we are talking about the standard one, that is limited to a region, or it is like going through regional channels. So there will be multiple hops or multiple paths to reach to or provide you access to the Google resources. Now, if you can see the very first diagram here, okay, so in the premium option, if you see, we have resources into somewhere like there is our organization setup or the data centers of Google Cloud region. Okay, now premium routing is like a cold potato, is what they have termed it as. Okay, which minimizes the distance and hops, like the number of steps it is going to take to get access to the resources to the end user. Okay, so it is going to result in a faster and more secure transfer. Because if you see this path, I mean there is a meaning of this the color coding of blue, right? So here it is not leaving the Google Cloud infrastructure or Google Cloud network unless it is reaching to the nearest point of the end user's network, right? So it's like point of presence of this network. So you have the Google Cloud infrastructure resources, like it is suppose I have some computing and instances deployed somewhere in European region, maybe you can say Europe West 1, West 2, like that. Okay, now I want to access that resource sitting in India at my home with access to the internet through my internet service provider, right? So as soon as try to access the resource and I have the premium tier enabled for Google Cloud, okay, so it will try to get me access to this resource by moving, I mean, enabling the network connectivity from this region to some region which is very much near to my place. Like it can be reaching to the network connectivity of somewhere in Mumbai region or maybe Delhi region, right? And then they, or you can say just India as a particular continent here. Now they will have multiples of point of presence, POP, that is what we call. Okay, so they can be present near to the actual region, or there are multiple other edge points or the point of presence, right? I have showed last time there is one edge point of present as HNI as one place, right? So similar to that, there can be multiple other also for multiple countries. Okay, so now this network is going to take, or the connectivity, the connection is going to take an exit to the internet. Okay, so far it is only within that Google's own network connection, I mean internal network, the internal network that we were discussing with these cider notations and all, right? So far it is still internally moving from to the Google's own network, and then it is taking an exit which is very much close to my own place, I mean my own destination, where from where I'm trying to access this particular resource, which is actually present in some other far away from my own location, right? So that is where the premium tier is actually not only faster, okay, but it is also secure, right? Because it is not going to the public internet just immediately. It is taking exit very less. So now if you see the number of hops, if I say this is going to be my first hop or the first initial step, then it is going through the multiple steps of within the Google Cloud environment, Google Cloud infrastructure. If I take the hop as the second hop, and then internet service provider, the router itself becomes the third one, and fourth hop by fourth hop, it is reaching to my system, okay, with which this I mean the internet connectivity is established between the internet service provider and my computer, right? So by fourth hop, I'm able to make access to this particular resource, okay, and that is much faster comparatively and secure. Same thing if you see in standard tier, it is taking an exit immediately within same region, okay. So suppose if it is in Europe region, Europe West 1 or West 2, so it is going to take an exit from the point of presence in that region itself, okay. So traffic is taking an exit from Google Cloud Network near to the source. The source becomes the US West or West 1 or West 2, okay. Now from there it is actually revolving with the public internet, okay. And that's the reason it is going with multiple channels, like there can be a internet provider in that particular region. Now that is moving it to another I mean, if it is much better infrastructure, if you are using some better I mean internet provider, okay, so that may reduce the number of hops, okay. If you are using very much a local internet provider, okay, so then it is because they are going to land the network from other bigger providers, right? So that is going to increase the number of steps by when you are able to get access to these resources altogether, right? So here you can see how many steps you have: 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, and the 11. So that is actually adding up to the latency of how you are able to access this resource. But this is more cost effective. So depending on our use case, we go for either premium or the standard tier of this network that we utilize, or the network that we opt in the Google Cloud infrastructure. Okay. Now, here let's see another picture here. So in case of premium tier, you have the global load balancing. The VIP is nothing but the virtual IP or the public IP that is assigned to the global load balancer. This is for the front end. Okay. Now, when we use the premium tier, it will hit to this virtual IP which is assigned for global as a global resource. Okay. And then it will try to identify where is my resource available, or if it is present in multiple, if it is load balanced with multiple regions, right? So suppose someone is trying to access any of the resources, maybe from US region, so it will, I mean, the user will be actually hitting to this particular resource, which is already spinned up. It is running, because here we are talking from the load balancing perspective. So in case of load balancing, we deploy our resources to multiple regions if it is a global resource. So people from multiple countries, multiple continents, they can get access to resource quickly, because we try to redirect them to the nearest of their presence, right? So if someone is trying to access a resource sitting in US, I will be pointing it to the VMs or the computing gen VMs which is present in US region. If someone is from the European country, it will be redirecting to this European country only, and similar to that, Tokyo or India or any other country or the region, right? So that is how the global load balancing VIPs are assigned in the case of premium tier. But similar to that, if we look at the standard tier, there it is assigned at the regional level, right? So now it is going to be additional effort. Also, the load balancing is done in a region only. So here the use case would be if the customer of your environment, like whenever I talk about the compute engine instances or any sort of workload, maybe a web server is running, they are serving some request, they have some specific use cases they are serving, right? Now and the customer around it will also be residing somewhere. So in case of premium tier, if I have a global customer base, in that case I will obviously opt for the premium tier. But in case of standard, only we are going when we have the requirement or the customer base only present in a particular region. So in this option, if you see, the load balancing is actually, or the load balancers are actually deployed in a region only here. So I will have a regional load balancer deployed for US, then same thing for European, and then for Tokyo, right? For Japan. So I will have a separate load balancers deployed there, and then they will have multiple other instances. Okay. So here, if you see, though it says that, the, this sign is actually for the compute engine, right? But it is not just single compute engine, but a list of, a huge list of the compute engines, right? It can be hundreds of it. That's where you are again seeing this IP range. It's a subnetwork range, you can say, where these instances are deployed. Okay. And obviously, if you go through this pathway to identify or to make the right decision whether you should be opting for a standard or the premium tier, you can just see how the workflow goes. So for the cost effectiveness, if it is price sensitive, I should be going for the standard one. It should indicate here, like, you see, start here. What's the most important for this workload or the resource? If it is cost effective or the price sensitive, like we want to save a lot of cost, just notice on the yes part, right? Yes, do you want to deploy your workload or the backends or have users in multiple regions? If yes, then you are going to this direction. If no, then you are going checking again if it has the high performance, availability, low latency requirement or not. Okay, so if that is not the case, again, let's say if you want to use the global load balancer or CDN, even if that is also not true, then I will just use the standard tier. Okay. Now I can also check if I want to use the public IP address, public internet instead of Google network for international or cross region traffic. Okay. If that is not true, then I will go for no, that is premium tier. If it is true here, again I will go for the standard one. Okay. So that is how we decide, but on high level, again, it depends on the presence of your user. If it is global, premium. If it is regional, then standard. Again, if you want to save the cost, go for the standard. If you want to save, you don't have the cost concern, go with the premium one. And also that will come up with the sensitivity of or the latency of the service that you get. Okay, I hope that is clear for all. It's not that tough concept. Okay, so now let me move on with the next topic. The next one is to talk about the CIDR range. How many of you have the clarity on the CIDR range now?
Yeah, for me it's clear.
Clear, right? Okay.
Yes.
So let's go to the CIDR range once more, just to cover it. So let's see. Give me a second. Yeah. Okay. So for CIDR range, as we had discussed last time, so this is a way to calculate what should be your overall, the network size. Okay. How you split it into sub networks, and how do you define what should be the IP range I should be using for my workloads. Okay. So as we discussed, the highest one, or you can say the lowest number, or the number of IP addresses that can be assigned to one compute engine, which is going to be count of one. In that sense, we need to have the forward slash 32. That is being the least number of IP range which is available to be utilized. Okay, it works with the concept of the binary 0 and 1 formula. You will have four octals. Okay, so each will have different flexibility based on what is the range you have taken. Now in this scenario, like I have selected slash 32, so I have only one IP range available to be utilized. Okay, which is going to be 10.88.135.144. Okay, as soon as I change this range from 30 to 32 to 30, that is 30. Okay, so here the formula works like 2 to the power n, right? So in this case, as I'm reducing the number of or the size of this the range, okay, starting from 32 till 0 we can go with the public net, but here we are more interested from the internal traffics or the networks that we create internally, the internal network that we are creating, which is also called RFC 1918 is what we use mostly here. Okay, so that is for internal networks. So here, as I am reducing from /32 to 30. Okay, so now if I take consider the formula of calculating the number of IPs being available to be utilized. Okay, so here 32 minus 30, which is remaining 2. So 2 to the power 2 will be 4. Okay, that gives me 4 available IP ranges to be utilized. Okay, so similar to that, whenever I'm designing my networks, I can have I mean there are different patterns that we follow. Okay, but mostly we have seen we use /24, we use /20 based on what sort of workloads I have. Okay, so here if you see, as I'm reducing it, so let me go back and then make it maybe 28. Okay, so /28 means I have around 4 octal that can be changed. Okay, the binary values that I can change, the 0 and 1s, right? So you can see the one which is highlighted in gray. So in these are the you can say values that can be changed, updated, okay, to adjust or to come up with the new IP ranges. So here if I am using one like a 0, the values can be like a 0 1, right? So I have here 4 zeros. I can have 0 0 0 and then 1. Similar to that, I can have 0 0 0 maybe 0 0 and 1 1, like that. So similar to that, there can be a 16 combinations altogether, and that gives me 16 IP ranges to be used. Okay, there are a few which are actually hold back for the broadcasting, or they can be there can be some base IPs. Okay, in case of cloud, they reserve a few more, like I think they reserve around 4 IP addresses, two actually. So base, and there is one more. Okay, so normally it starts with 0, I mean .2 kind of, if you see. So there are different ways to look into from cloud perspective, but this is on high level how the CIDR ranges are created, what they mean. Okay, and they are very important concept when we are creating any networks. Okay, fine. So that's about the CIDR ranges. Let's move on with the next concept, that is about cloud net, which is also called cloud network address translation. Okay, let me share the next screen here. Okay, so as I said, the next concept is about cloud cloud network address translation. So okay, so let's see. Okay, okay. So now, anyone remembers what we had discussed last time about the cloud net? Do we see this? So it says that it provides outgoing connectivity to resources without external IP addresses. So from the security perspective, we want to ensure that we are not enabling any of the public IPs on our resources, whatever we create. These are indicating like this is a compute engine instance. Similar to that, here we have Kubernetes, we have the cloud run, cloud functions, okay, and there are some other resources as well. Okay, now we don't want to have a public IP assigned to them, but these are kind of computational resources which require some sort of software updates. I mean, very often, if there are any available, like we discussed this the patches, security patches question sometime back, right? So similar to that, we have the requirement to update the software installed on either of these machines, right? And we don't have the external IP assigned to it, again from the security aspect. So what is the other way of letting them access the internet, but do not let internet be allowed to access these resources, right? to save them from external shocks, any kind of external people trying to access it and try to hack these systems, right? So there is a concept of cloudnet. Okay, here it provides us the more of security. Obviously, we want to have more availability by using these services, by updating these services. It gives me more performance and scalability because of the service, right? Now, let's see how this works. And first of all, how it is different than the other net proxies, right? So here, if you see, there are two parts of this particular diagram. So if you see in the on-premises scenarios, like whenever, even for the on-premises also, we will have this concept, right? So even in that also, we don't expose the public IPs, and we go through the cloud. I'm not the cloud, but only the network as address translation proxies, right? So if you see the actual difference here, so in case of on-premises, we had the physical data plane of physical proxy servers running, and all of these communications, whichever these virtual machines, they try to access the internet, it was going through a proxy server that was a net proxy. Okay, it was actually physically deployed. Now, but in case of cloud, we don't have any physical proxy servers, but it's a more of a logical one. I mean, it's a virtual one. Okay, so there is actually not a proxy server running. Okay, but they are assigned, or they are working through a port assignment. Like all of these machines, whichever is trying to update their patches or download any applications from the internet, they are being assigned a port with it. Okay, so if you see in this scenario here itself, I have a you can say the net IP as created. Okay, this is from the cloudnet. So whenever I mean, it is trying to interact with the internet, the actual IP address that is exposed to the public internet is the net IP. I mean, from coming from the cloudnet. Okay, so there is a IP address assigned for the cloudnet service. Now, whenever we are trying to make any updates to our resources, the compute engine or the Kubernetes or maybe Cloud Run, so they are actually interacting with this cloudnet service by having a port added to it. Like suppose I have take this VM, okay, VM IP3. Now this VM will be accessing accessing this cloudnet service by having the 203.0.113.1 / and then it can have a port added to it, a port number added to it. Like I can have 32.0.0.1.0.2 like that. Okay. So with that, it will be accessing this cloudnet service, and cloudnet is having access to download the resources from internet, right? So there is actually not a physical setup, but it's a logical net gateway that is created. Okay, and that's how we are actually able to reach to the public internet, and then able to download whatever updates I need to do, maybe another application or the software. Like if you have tried to update your, like if you are working with the Linux machine, you must have been running a sudo git update, like that kind of command, right? So all that works if we have this setup added or created with the cloudnet. Okay, if you have not enabled that, and the operating system or the computer engine VMs that you are accessing, it only has the public the internet internal IPs, so it is not going to let you update your files. I mean, it is not going to let you run those commands. Okay, so you need to have this particular component added, and it should enable you access the internet. Okay, that is on very high level this cloudnet is working. Okay, which you can see here in this basic configuration of this cloudnet as well in this scenario. So in this particular picture, if you see on the high level, you have some update server, like update service, like some URL from where you are downloading these updates, right? Maybe if you are running the Linux commands, so it will have a Linux URL from where you are downloading these updates. Okay, so it is being accessed through the internet only. Now the internet access is only enabled for the cloudnet service. And make a point here, make a note of this point. Cloudnet service is deployed per region because they are working with a particular subnet, not with everything, right? So here I am deploying my cloud service into a particular region. In this case, if you see, it is being deployed in a US East 1. So anytime it is trying to access to the internet, it is going through this region only. Even if you have your components or the resources deployed anywhere else also, but the servers or the updates are going to be downloaded through the cloudnet, which is installed or created in the US East region only. Okay. Now, when it is trying to interact here, you can see the subnet 1 and subnet 2. So subnet 1 is actually accessing the cloudnet, okay, through the ports, obviously, but they are added as part of letting them use the cloudnet. But in case of subnet 2, we are not allowing it, and that's where it cannot make any updates to its software, right? So these are the differences. So here I have enabled cloudnet for this particular subnet, but for subnet 2 I have not allowed it, and so that's it is not able to install any of these updates. Okay, is there any question with this particular set of topic, cloudnet? No? Shall I move forward?
Yes.
Okay. So see, the thing is, if you want to experiment with it, you can just visualize what is there in this particular setup, right? You don't have to go much deeper. Otherwise, if you are not something on the networking side, but for now, if you want to experiment with this particular kind of services, you can definitely go ahead and then check it out, how it looks like, and the way it is saying that it is only available in a particular region. The subnet I need to select for which subnet I'm allowing it. Okay, so that is how you will be able to understand it even better. These are important topics from the overall setup, like from the infra setup whenever we do. Okay, yeah, okay, so let's move on then. Okay, so yeah, now the next topic is going to be cloud load balancing, which is a little longer. Going to be it is very important. It is also a bit of adding a bit of confusion itself, so need to be a little more attentive here. Okay, and there are if we try to break it from multiple components also, there are multiple pieces of it, how we decide which particular type of the load balancer I need to use in what scenario. Okay, but let's try to see if it can be understood on very high level, to have at least the least knowledge that you should have, right? So let's give attempt it. Okay, give me a second. All right, okay, so let's see. Okay, so in case of load balancer or load balancing, what do we really understand from it? What why load balancing we need on very high level anytime? In general concept also, anyone?
Okay, in general concept, I will tell you load balancing in the terms of if number of requests are hitting for a single server, okay, then maybe if server goes down or something, so if it will be balanced in the multiple servers. So if whatever the server is there, one concept is the round robin. Okay, so
right.
whenever different requests are coming, whichever server is free, it will go to that server. Like that it is happening. So load will be balanced in the terms of hitting on the website, so website never goes down.
Okay,
Like
that's a good understanding, Raju. Okay, anyone else? Naresh, you must have worked with load balancer anytime. You must have deployed backends.
Yes, exactly I don't know, but we were using like when it reaches the threshold like 80%, so another instance creation.
Right.
So for that we are using load balance.
Okay, that is more of an internal load balancer.
Okay.
Like internally, it is deployed whenever there is a more of workload. It will trigger the internal load balancer so that the backends are scaled.
Yes.
Okay. Who else has worked with the load balancers? Maybe the front end load balancer or the backend. Vijay, have you worked with the load balancer with your Java skills?
No, Jitendra.
Fine. So let's see what is a load balancer first of all. Obviously, as we have talked about so far, so it is going to provide you more of scalability, right? Because as soon as you see there is additional workload, it is going to trigger the backend so that multiple other instances of the same servers are or the replica of that servers are installed. They start spinned up and they are serving the request, right? So it is giving more of a scalability if there is a need. Then also it is going to reduce the latency because it is not going to wait for just one server to serve all of the requests, but will again add additional servers to serve the request, and that is how it is reducing the latency as well. Actually, I should not explain in this way. The reduction in the latency would be another set of concept. Like just now we saw this in case of the networking tiers, right? So we saw that if we were using the premium tier, it was using a global load balancer, right? In that case, it was actually pointing out or redirecting the request to the closest instance of the user, right? So if the request was coming from European country, it was moving or redirecting the request to the instances which were running or deployed in the European region. Okay, so that's how the user did not have to wait a lot to get their request being served. So that is how it was actually ensuring to reduce the latency, right? Then it also talks about the increased security because again, if suppose there are any sort of the attack of a lot of requests being done from some hackers, some other setup or automated setup, right? So now that can be enhanced, that can be taken care, and that will secure your application because here you are not losing anything just because it is getting load balanced. Okay. Now, how it can be a reduced cost? Anyone can, think through it. How it can be reducing the cost? Anyone, any thought that comes in your mind? If it is scaling up, can it also scale down if the workload is not there?
Yes, it can be scaled now.
That makes sense.
Yes.
Okay. So when you have the load balancing in place, you can define how many instances should be running all the time if there is a workload. If there is no workload of, or if the number of requests to be served is very less, okay, cut it down to maybe few instances only, or just one if there is no workload at all, or even you can go to zero itself, right? So that way, you are only going to be charged whenever there is something to be served, otherwise no, right? And which is being controlled through the help of this load balancing concept. Okay. So on high level here again, in case of cloud computing, the cloud load balancing is actually nothing but a SDN, software defined networking. Okay. Here we are not having any physical setup, okay, which is actually now replaced with a virtual kind of networks, or the way they are defined now. Okay. Here we are assigning a single global unicast IP, the public IP that we are talking about. Okay. This is applicable in case of premium tier. Okay. So in case of premium tier, we are assigning a global unicast VIP, and through that we are trying to load balance our resources. Okay. The fast auto scaling, we have understood that concept. Single point to apply global policies, like you have to apply it only to this the the IP address that you have in place, or the load balancer that you have created, right? It is very much performant, so it can serve around 1 million requests per second, queries per second. Okay. It works with the cross region failover and fallback. So here, if some of the resources are not accessible, not available in a region, load balancer will take care of making it available in another region. So even if it is going to add a little bit of latency, at least you are still able to access the resource, right? So that is also taken care when you are going with the, I mean, you have set up a load balancer for your workloads. Okay. Okay. So now let's go to the second part of it. How does this load balancer works? Okay. So you see here, a bit of we had discussed about the cloud DNS, like it helps in resolving this URL what you're seeing by checking what IP address it is linked to internally, right? So now this URL has a IP, my app.com has a IP address linked with it, which is 200.1.1.1. Okay. Then I want to see how to access or access the resources which is actually being load balanced through this IP address. Like, so this is the IP address I have. Now it is going to check like with this IP here. If you see, global load balancing is enabled here, okay, for this particular IP address. Okay, what it is going to do, it will check from where the request is coming. When someone like here in this scenario, if someone named Maya is present in California accessing the resource, I mean their IP address from where they are accessing it, if that is 50.1.1.1, okay, they will be I mean they will be redirected to access the resource, okay, like the request whatever they are going to make to access these resources, that will be redirected to the nearest region for them, which is going to be region US West 1. Okay, so it is going to hit to the front end server of that region. Okay, now that is for the front end side. The front end is going to pass on that request to the internal load balancer. So we have three components wherever we talk about the three-tier architecture. Have you heard of three-tier architecture anytime?
Yes, I heard about that.
Okay. Did you try to deploy that anytime?
No.
Okay. We will do that as part of the project if you are not coming up with your own concept. Okay. So I have one three-tier architecture that I use for demo, which definitely we can use for your work as well. Okay. Fine. So here, if you
That
see
we can
there,
share, explain to the interviewer also.
yes, you can.
Okay.
Okay. Now let's see. So in this scenario, you have, I mean, you as a user going to access a resource that is my app.com, which is deployed in Google Cloud environment. So as soon as you try to access this resource, my app.com, it will be hit by the cloud DNS, which will resolve that IP to 200.1.1.1, which is actually linked with the global load balancer. Okay, the global load balancer is going to check from where this request has come. Okay, it will have try to capture the location information. If it identifies that it is coming from somewhere from the California, which is again a US region, okay, so if it is coming from US based region, it will redirect that request to the front end server which is deployed in US based region. Okay, then now the front end is going to check, I mean pass on this request to uh, the internal load balancer. Okay, so it is going to pass on it to the backend service. The backend endpoint is where it is going to pass on. Okay, now from this backend endpoint, it is going to serve the request. It will have whatever workload that you are requesting for. So it will have that all that setup, and it will also have the data layer, the databases that from where it is trying to fetch all those information. So this is front end server, this is the backend application, and this is the databases which is integrated with the backend application. Okay, these all together are actually serving the request, returning it back to the front end server, and then the information is being sent back to the user, right? So what role it is playing for from the global or the load balancing aspect? The global load balancer is in checking from where the request is coming, and based on that, it is moving the redirecting the request to the closest of that particular request. I mean the load balancer, okay, and serving that user, right? So in case of Maya coming from California, they are being served from the US West region. In case of Sen in Singapore, that is being served from the Singapore region. Okay, and that's how the load balancers are working. Is there any confusion here? Anyone? No? Okay. So now let's look into the next concept, which is the data model of any of this uh, load balancing, right? So we have two concepts here. One is for the global load balancer, which is on the internet side, and the other one is for the internal load balancing. Okay. So on the top, you will see you have the internet, okay, which is having assigned this external global IP, the anycast IP or the public IP. It is forwarding, having some forwarding rules like whenever the request is coming here, you will see what all IP addresses are there, what protocols are assigned to it, what are the port that is being used, right? So based on that, it will have some rules created, and that is how it is going to move the request to a target proxy server. Again, there also will work with the help of like URL maps or the IP of that host or the path rules. Okay, so there can be a set of rules that is defined. You don't have to go and go overthinking on this part. Just think that there are set of rules which are defined to help us pass on this request to the backend service. Okay, from here, from internet or the user who is trying to access any of the resources, they are kept on forwarded to a backend service based on set of rules. Okay, and then backend service is going to check if it has the right set of capability or the capacity to serve the request. Also, it will see if a instance which is going to be used here, if the instance is available for use or not, like if it is the instance is healthy or not. So health check is also very important concept here. Okay, so again, if I repeat, end user trying to access any resources, they are being forwarded through the global forwarding rule within the environment as soon as they hit the server, right? And then it is moved through the target proxies and the backend service. Backend service will see if it is able to serve it. Okay, if it the instances which is going to serve your request, if that is available and healthy. Okay, if not, it is going to create one more instance, like it is going to scale up and then serve the request. So there are a concept of in case of compute engine, there is a concept of managed instance group, MIG. Okay, these MIGs are nothing but a set of similar instances, like the web servers only. Okay, or maybe uh, uh, maybe some other application servers. Okay, but they are grouped together, and they ensure that if there is an additional workload required, they are going to scale. If it is not required now, then scale down also. So that is how these managed instance groups are also taking care of my request. Okay, and they are nothing but our backend. Like the requests are coming from here, right? So they are going to the backend, and then these backends will also, I mean, the firewall rule we have worked upon, right? So we saw that how the firewall rules are created, how we use a network tag for assigning the firewall rules to this list of VMs. In our case, in the lab, we did only one computer engine instance, but same thing can apply for the thousands of VMs as well. And the thousands of VMs here in this scenario, if you see, is what I was talking about, the managed instance group. Okay, the VMs which are similar in nature, doing the similar task. Only thing is that they can be scaled up and down based on our workload. Okay. Okay. So that is how the requests are served there. Now, how I want to actually secure it, that also we had seen when I was talking about this global load balancer clubbed with Cloud Armor and IP to make it more secure. Like Cloud Armor is something on the web application firewall on the front end. Okay, and also it is linked. I mean, another service is attached to it, which is Cloud IP, identity aware proxy. All together, they secure your setup, the cloud load balancing, and that is also part of a best practices. Now, here is the overall picture that I was saying that it can be a little confusing for you all. Okay? Even for me also, still it becomes a challenge. So how do I choose the right load balancing option? First of all, let's see what all things we have here. Please be a little tentative here. And try to grasp as much as possible. So there can be IPv6 and IPv4 client. The IP addresses so far what we were seeing, they are IP. Okay, which one it is? If anyone has experience with this IP address types, so which one is this IP address? This one. Is it IPv6? Yeah.
It's
IPv4.
Yeah.
IPv4. And how does this IPv6 look like?
Some numbering, extra numbering will be there.
Okay, there can be some columns as well.
Yes.
Right.
Yes.
See,
Yes.
and why do we need? I mean, we require to have the IPv6.
Actually, IPv4 IPs are not getting, very less are available now because maximum are getting used already. So
Okay.
to overcome that one, that IPv6 concept came in the picture.
Right, that is absolutely right. Okay, so now we also have the IPv6 addresses that can be used. Okay, they have more IP ranges. So slowly we started moving into IPv6 also, or enabling it parallelly, IPv4 as well as the IPv6. Okay, if that is clear, now let's move to the next component. In case of load balancer, we saw there are two types of load balancer on high level, or two segregations of load balancer. One which is deployed in the front end, another one which is deployed in the back end. Okay, the front end one is the external load balancer, which is directly interacting with the internet. The one in the backend, that is actually internal load balancer, which is actually trying to make communication for the internal only IPs. Okay, so if that is also clear to you now, the external IP load balancer and the internal load balancer. Now let's see what are the various types of external load balancer first. Okay, so on the external side we have the HTTP and HTTPS load balancers. Okay, like which is serving the HTTPS or HTTP traffics. So HTTP is what? 80, right? Column 80. Okay, and HTTPS is a 443 /443, which is more of a secure HTTP request or traffic. Okay, so that is for that. There are few other set of load balancers, which is one is TCP. So TCP is what? Transmission Control Protocol. Okay, so this is again a more of a secure channel of communication. Okay, and there are a bit of a flavor of it. So one is for SSL and another one is a TCP proxy. So SSL proxy and TCP proxy, two things with the TCP itself. Okay, now in that the SSL one is secure socket layer. So here you need a certificate, okay, on the client side, and there can be also for the server side to be installed, so that you can establish a communication. You encrypt your data before you actually transmit it to the to the any of the data, right? Like I was talking about the data encryptions in the security part, even on the data. Yeah, so data encryption is what I was talking from the security service, right? So there they will use some sort of SSL depending on whether we want to enable it or not. So there is a concept of SSL proxies, and also there is a TCP proxy. Okay, now if you are using the SSL proxy, you need to offload whatever request you are taking that to a SSL proxy server. There will be another server. These are nothing but a load balancers are nothing but a proxy servers, right? They are actually filtering out whatever request you are making from the internal resource. They will check it whether what kind of rules they have, why I need to serve them or not, whether it is coming from a valid location, valid IP. Okay, so based on that only they are going to serve it. So here I have there are multiple flavors. They have different scopes for them, right? So HTTPS load balancing, SSL proxy load balancing, and there is one more called a TCP proxy, where you don't have this SSL certificates. Okay, so you don't have to offload them, and they are passed through the TCP proxies. So that is the TCP traffic, where you have SSL or without SSL. Then there is one more, a UDP, user datagram protocols. That is more of like a you know that even this app what we are using, Zoom and all, right? So there can be some sort of network delays, or we can lose some packets, right? But it should be communicating all the time. I mean, I cannot have it stop. I don't want to. It is more of performant, you can say, in case of UDP. Okay, so I can compromise on the packet losses. I just need to ensure that it is like a more performant. Okay, so performance is more preferred in this scenario compared to whether it is actually serving every packet or not, the data packets that is being transmitted, right? So here I will have the UDP traffic. Again, it will check whether it's a IPv6 client global load balancer, or if yes, then you don't have any other, like it is going to be none that you go for. If it is no, then we will check whether we need to have what you can say it. So here in case of UDP traffic, if you see, no, one thing that it is highlighting is it is actually for the network load balancing. So there are two concepts, like the HTTPS load balancers, okay, the external load balancer that we talked about, and there is one more for the networking load balancer, which is deployed only one region. You can also see it says so. Yeah. So if you say it is more of a regional resource, so UDP traffics or UDP load balancers are deployed in a region. HTTP are the global load balancer. They are deployed globally. Okay? HTTP and the TCP, these are also a global one. Okay, you can see here it says that similar. So global, these are the global load balancers. So you have HTTPS, SSL proxy, and TCP proxy. But in case of UDP, it is actually a regional one. It is serving within a region only, and also called as a network load balancer. Okay. Now, apart from this, if you see in case of TCP, we have the global load balancer, or if it is without any SSL offloading, okay, then you use the TCP proxy. Then we also check whether you want to preserve the client IPs or not. Okay, so in that case, again we use the TCP proxy. If you want to preserve this client IPs, I mean the client IP is what I am trying to access these. I mean try to request some resources, okay, directly. So here it is going through the proxy servers. Okay, but suppose I want to keep this IP addresses, whatever was from where the request is coming. If I want to use that and take it to the backend, this is again I'm reaching here in the backend system. This is for the external one. Okay, front end. This is for the backend. Now, if I'm passing on that IP address details to the backend, that means I'm preserving those IP details. I'm not offloading it somewhere here in the proxy server, and then proxy server is going back and then checking with the backend and get me the details and then pass it back. That is not the case in the preserving the IP client IP addresses. In this scenario, I'm actually passing on those IP details and then giving it to backend, and then backend will do the work for me. So there I'm using UDP traffic. So that is from the front end side, external side. But in case of internal one, this was this whole picture, whatever you are seeing here, okay, this part, that is more of a external only, right? Something coming from the external side. Now the next part is, suppose I'm not talking about any of this internet enabled components, or the request that I'm trying to serve from the request that is coming from the internet, from the public IPs, from some user. I'm not doing that. Now I'm going to look from the internal communication, like I have application, internal application, which is deployed in the backend, which you have seen here in this scenario. This is my internal load balancer, right? This can be my middleware where I have the application servers are running. Now, suppose this wants to communicate with the databases, okay? That also needs some sort of load balancing, right? Because that is also a workload itself, and that has to be served through some sort of load balancing. That is where I'm talking about these internal load balancers, okay? And they will also have the concept of TCP, okay, which will have a lot of range of ports, okay. But in case of HTTP and HTTPS, what port we are using? What port are we using for this HTTP and HTTPS?
80 and 443.
Right, okay, that is limited to that only. But in case of TCP and UDP, we have a range of ports that we can utilize, okay. Like for 2.5 we use for email communication, I believe, right? That is part of the TCP. So Similar to external one, we also have the same set of load balancers, which are used for enabling the communication from internal instance to instance traffic, and that is going through the internal IP addresses only. There is no public IP involved in case of internal load balancers. Okay, the load balancers remain the same. The internal like TCP UDP load balancing, internal HTTP load balancing, and there is a network load balancer like again TCP and UDP load balancer. These three types of load balancers are present in case of internal communication. So on the gist, this is what load balancing is about. Whatever I've explained so far, that should be enough at this point of time to make a little bit of sense. You have to go again and again to understand it better, but for now you should be good. If you want to deep dive into that, definitely go ahead and then look into the documentation about what are the different load balancers on it. Okay, so that is about the load balancing. Let's move on. Before that, is there any question about this load balancing part? No? Okay. Okay, so let's do one thing. For now, we are done with the most of it, like network service tier, CIDR range, cloud net, load balancing, load balancing. Now we are left with the cloud network connectivity option. Again, that is very important, and I don't want to just make it on hurry. Okay, so let's do this tomorrow. Okay, and with that also we'll include some labs as well for the networking, right?
Okay.
So fine, let's continue tomorrow then on this part, the network connectivity, and there will be some labs, and with that we'll conclude the networking part of it.
Okay.